Hey everybody, welcome to CS302 assignment 2. And for this assignment, we're going to implement this 8 queens game or puzzle, if you will. And the way this puzzle is really done is you have a standard 8x8 chessboard, and the idea is you want to put down 8 queens onto this chessboard in such a way that none of the queens will be able to, I guess, attack each other. So on a chessboard, a queen is that, well, I guess in chess, really, the king is the most important character because once a checkmate happens, the game is over. But in reality, really, that I think the queen is the most important player in the chessboard because the queen can really move. It's a very versatile character. So the queen can move any number of directions in a horizontal direction, vertical direction, or in diagonal direction. So it gives the queen a lot of power. So whenever you play chess, if you lose the queen, you really, in a sense, you might lose the actual game as well. Anyway, so in this one, we want to essentially just put the 8 queens down in that way. So in this program, you're going to just be given the initial coordinates of the first queen, and anywhere it can be placed on the 8x8 chessboard. And then you have to write the code that's going to essentially place the 7 other queens onto the board, such that all the queens are not able to attack each other is the idea. So this program is going to use recursion, recursive backtracking to solve it because really there's no real obvious way to solve this. You have to actually try multiple possibilities. You may have to try one possibility, go back, and then retry a different move. So let's go ahead. And of course, here's all the writing on the very first page of this PDF. Let me go ahead and just give you the idea, sort of a nice visual idea here using OneNote. So let's go ahead and get to it. So as mentioned earlier and also in the PDF, this is going to use recursive backtracking, or otherwise known as recursion, to solve this problem. Because the idea is, as we place queens in certain spots on the board, we can't guarantee that that's going to be the final position for each queen. You may have to back up or go back to a previous spot and reposition a queen somewhere else until we finally get a valid solution for the 8 queens problem. So you're going to probably have to create a two-dimensional array of some sort to simply store the locations of where the queens are and possibly even mark which locations are safe and unsafe to make it a bit easier to determine where a queen can go. And the output to the user, we display rows 1 through 8 and columns 1 through 8. But in reality, as we already know, we go from 0 to 7 for the rows and 0 to 7 for the columns. So just remember, it's a simple offset we'd have to do. So for each example run, we're going to have an initial spot for the queen. So the user, this is actually one of the input formations given, or one of the sample runs given in the PDF, where the initial queen will be placed on row 2, column 4, which really means to us row 1, column 3, because remember, index 1 is the second row, and index 3 is the fourth column. Okay, so now that we have our queen placed at this location, let's go ahead and now sort of visually trace out how this algorithm would actually solve the 8 queens. So recursively, we would actually solve the first row. Now, you actually could do this in a column by column. You can solve each column individually, but I guess I'm going to go ahead and do it a row by row fashion. So I'm going to first try to solve the first row. So on the first row, which is really just this row right here, I want to find the first location where the queen can go. So going from left to right, I notice that right here, this is a safe spot for a queen to go. Because, or before I even put this down, if you look at the queen right here, the initial queen given to us, essentially, this queen, these locations right here, are actually not safe. Because in these spots over here, this queen is able to attack those spots. So no queens can go in those locations. And of course, in this diagonal direction as well. And I think This is the other one. So these locations right here are not valid. No other queen can go in those locations that I just sort of lined out right there. So this spot right here would be a safe location for a queen to go in this row. So what happens is, okay, cool. So we found this location right here that is safe. Let me go ahead and just unmark this now. So now that we place the queen in this row, we want to go to the next row. So what's going to happen is when we go to a new row, we're going to have to recursively call a function and pass in some value that tells this function which row we're going to be currently working on. So what's going to happen is we're going to save the progress because right now, the queen going right here, it may have to move somewhere else. We can't guarantee the queen will go in this spot. So the next row, we go to the second row over here, and we already have a queen in this location. So we also want to store possibly the initial row. So we know that, oh, row index 1 already has a queen because that was the initial input given to us. So we can skip this row and just jump to the next row, basically. So the idea is, now our next recursive function, we're going to now process this row. And now the function above, which I guess we could have two functions, because we could have one function that's currently on this row, another function above that on this row. Or you could actually maybe not even call a function on this index 1 row at all. So you can skip that row entirely. It's up to you. I think I actually called the function on that row either way, but it doesn't really matter. We'll just say for now, maybe just you didn't call a function. So right now, we currently have one function on the system stack at row 0 that's paused. And now we're on this row index 2. So I want to find a safe location to place the queen on this row. Now as we traverse, we see that this spot right here is not a safe spot because we can see the queen above would attack that spot. So you can't put a queen there. Over here actually would be safe. So we can put a queen in this location. It would definitely work without any problems. So what happens now is once that happens, we're going to now recursively call a function to go to the next row. So each function body is going to have a for loop that will iterate through that row until it finds a safe spot for the queen. And once it does put the queen down, it will place the queen down, and then a function will call, recursively will call another function, but it will save its progress. So we gotta know exactly where we last left off in the previous function or functions. So now, in this next row, index 3, we can't put a queen there because that's an unsafe location. Can't put a queen there either. In this spot, we can't put a queen either because a queen above, this queen would attack that spot, so that's also not safe. We can't put a queen there because that would also be attacked by this queen right here, and also by this queen right here. Both attacks, so this would be a very unsafe spot. In this location right here, that would be a safe spot for the queen to go. So we have to kind of loop through this row until we finally found a safe spot. We place the queen down, and then we're going to recursively call itself, but pass in another row index. So that way each function knows what row it's going to be currently working on, and we stored the previous spots, the previous save points earlier. So if we had to return back to row 3, we would know we have to resume from column 4 and then try to place a queen somewhere else from that spot onward. So hopefully that idea makes sense. So now let's go to row 4. And over here, this spot is not safe because the queen above attacks it. This spot is not safe either. And this location, from eyeballing it, looks to be safe because it looks like no queen can attack this spot. So I think we're good. So we can go ahead and put a queen down over here. And then now we're going to stack this function, call a new function to go to row 5. And in row 5, we can't put a queen here. That's not safe. Or here, or here, or here, or here. Now let's look at this spot. Not safe because this queen attacks that spot, so we can't put a queen there. This location is not safe because that queen can attack it. And this location right here is also not safe because that queen can attack it. So we hit this moment right here where in row 5, there was no safe spots. Every column in row 5, it was not safe for a queen to go, which means that this row is unsolvable. So what we have to do is, since we're sitting on this function where our most recent function call is on row 5, we found no solution. So the result is we have to go back to the previous function call. So we have to return something back to the previous function. So we have to return back to function 4. We have to return something back to that function 4 that tells function 4 that, function when we went to row 5, there was no solution. So that tells this function where we're on row 4, it tells it that we have to resume actually. So what we do now is we're going to remove this queen from this spot. And then from here, we're going to resume. And now we'll try this location, not safe. This location, not safe. This location, not safe. This location is not safe. And this location looks to be safe. So now what we do, we place the queen in this spot now, and then we're going to, once again, recursively call the function and go to a new row, to this row right here, and we're going to try to solve this row, but we're entering it for the first time in a sense, because now we're entering row 5 with a different formation of our queens than we had before. So again, we have to now attack this row once again. So we can't put a queen here, can't put a queen here. This location looks to be safe from just eyeball. No, it's not, because right there, can't put a queen there. It's not safe. That's not safe. That's not safe. This location is not safe because this queen right here diagonally can attack this potential spot, so it's not safe. This is not safe, and this is not safe. So once again, row 5 was not solvable. No matter what I tried to do, no matter where I tried to put the queen in this row, it couldn't be not able to put a queen down. So once again, we have to return back to row 4, or to the function, the previous function where we were on row 4, and we have to tell that function that, the function that row 4 called. So this row 4 recursively called the function where row 5 was being processed, has to return some type of value back that tells it that, okay, there was no solution, so we're going to have to now resume from our current position. So currently on row 4, the queen is right here at this spot, but we can see that if we resume from here, we escape our loop, which means that now we can see there's no possible solution for row 4. So we have to backtrack from row 4 back to row 3. Now, when we go back to row 3, we have to tell row 3, we have to go back to that function and tell that function that, okay, row 4 couldn't be solved with this current formation. So row 3 is going to try to continue from where it last left off. It last left off where it tried column 4. Well, that's not good, so you have to unmark this location and continue from here. Now, this spot is not safe. This spot looks to be safe, so we're going to go ahead and put the queen here now. And then when we place the queen down, we're going to now recursively call the function again, and we're going to go to the next row. So then what happens now, we go to row 4, and now row 4 will start over again because we spawned a new function call. So from row 4, this column is not safe. This column is not safe. This column looks to be safe. Let me see, I don't see anything attacks this column, so I think we're good. So I'm going to put a queen down right here. And by doing that, that means, okay, so it looks like this works. So we put a queen down here, and we're going to stack this function up. And now we're going to now spawn a new function call. Where in this function call, we're going to pass in row 5. So we're going to try to attack and try to solve row 5. So from row 5, we start from the first column. Not safe, not safe, not safe, not safe. Doesn't look safe either. This is, let me see, this space not safe. Let me see, is this spot safe? Hold on. No, not because of queen above it. And this spot right here, is that safe? Nothing above it or below. Oh, it's not safe because that queen right there. So you can see how this is actually a real pain to trace it out. But eventually, if a solution is possible, eventually it's going to hit the very last row. And once the last row is reached, if it's able to place a queen down safely, that means the game is over. So then you have to, again, return back to the previous function, but somehow tell that previous function that a row below was solved. So that row was solved, then the current row has to be solved as well. Return a value back to the previous function that tells that function that the row below was solved, so, and so forth. So I would recommend maybe a Boolean return type. So returning a false means the current row couldn't be solved. So when a false returned back to the previous function, that tells the previous function call that, oh, the current information led to a failure in the next row, sorry. So then you have to continue from that spot. Returning a true means that everything was just fine. So a Boolean function of some sort would work. So anyway, this was sort of my trace through. So essentially, just as a reminder, what we do in each function call, run a loop. In the loop body, we just try to pick a column. Once we find a match, we write the queen into that spot. And then we're going to save the progress by recursively calling the function inside the loop body, actually. So that way we save our progress. So if we return back to this function, if we ever return back, we know where to continue from. We know which column index we were currently on last time in that function call. So I think I spoke too much. I don't want to over explain this and confuse anybody, but that's the idea. Let's go ahead and now just go over some final remarks for the assignment. So here's the output. Now once again, just remember, code grade input redirects all the input. So in order for the output to match perfectly on code grade, you have to actually output what you read in. So when you use cin, you're going to cin these two numbers, the coordinates. You want to also cout those. So that way it will display it, because on code grade it won't display the input on the terminal. On code grades, you have to cout it to make sure it displays it on the terminal. So 3, 4, here's our solution. Now, when I place a queen on and initially on row 3, column 3, I get no solution. Now, that's from my program, so I guess I'm going to go ahead and believe that it worked, because I'm going to go ahead and say I believe in the magic of recursion. So I'm going to believe my program works correctly. And row 3, column 3, there's no solution if I put a queen on that spot. So now again, if let's say you do find a solution that sort of contradicts my my no solution answer right here, just let me know, and perhaps I could even give us credit points if you actually do prove me wrong that 3-3 does have a solution. You give me a valid solution with a queen on that location 3-3. But at least for now, I'm going to say that mine gave no solution. I'm going to go ahead and believe my program. Then, of course, for 8-8, here's the solution, 5-5. So these inputs will be used also in code grade. And then right here at the very end, 8-1 has no solution either. So at the very end, here's that 2-4, which is the solution we had right there. And turns out that if you notice, look at ours. Initially, queen is on index 0, 0. Look where this queen is, on 1, 6. So it ends up backing all the way back to row 0, and it will try a new position. And it determines that eventually, on the first row, the queen has to go to column, I guess column 5, or in this case 6, but 5 in our representation, and it reconstructs everything from that point onward. So you can see how much it does actually do backtracking. But again, there's no way to do this without trying everything, essentially. So that was pretty much that. Now for the submission, actually, I think I didn't update the PDF, but you can submit anything you want. So I have it where I submitted just a main file, but you can submit a set of files together. If you notice on the output, I actually compile using G++ star.cpp, so it's going to compile any and all files provided and make sure you output what is input, so that way you'll match the same thing on code grade, so it makes it, I guess, I don't know, makes the auto test look better, I guess. So anyway, there's that. So hopefully this video, this explanation did help you. So I guess that's it for now. So happy coding and until next time.